So here we were. So we discussed about the evolution process, and also we have gone through the various diagrammatical representation to explain what is a evolution process. So this was a major diagram to explain the software evolution process, right? I'm just scrolling the screen. This was the major diagram that you need to explain the concept of evolution process, and you need to compare in an evolution what is the meaning of change implementation. So how exactly it is being implemented, that is a change implementation in software evolution process. And what is the meaning of emergency repair process? Even this could be a separate topic for a 2 marks or 3 marks or 5 marks. Explain the emergency repair process. So first you need to consider the diagram. When do we need an emergency? So that is important, right? So this has to be explained with this diagram. So emergency repair, maybe it is on deployment or a live running data. Got it? So the product has been evaluated or it has been delivered. So some sort of emergency repair process that may not be under that has not been identified during a testing process, or that may not be a part of our software requirement design, or else that may not be a part of software requirement specifications. Suddenly it had come, so we need to implement it and deploy it to the customer. So change request, analyze the code, modify the source code, and deliver the modified systems. The see here the code is you are delivering the modified system itself. So this is too important. So this is the concept of emergency repair process. So after that we had gone to the program evolution dynamics, layman's law we have seen continuously. This you just have to go through the table. He has defined few of the loose, that is what is inevitable maintenance. So layman's law, so few of the laws I just elaborated here. Maintenance is an inventable process. For example, here the system requirements are likely to change while the system is being developed. So change is inevitable. Okay, what is the meaning of change here? Is inevitable. So these are the things that you have to explain it. Now let me go to the important topic called software maintenance today. So these are the things I'm just recapping what we had covered, so that if you have not concentrated in the last class, at least you know what we have covered in the last class. Layman's laws we have explained. So it is a theoretical part. So in fact, one by one you have to explain what is layman's first law, layman's second law as such. Let me go directly to the software maintenance today. Okay, what is software maintenance? I request you, all of you, hear the session and you just give the attendance when I say. Before I start, so what is a maintenance? It is an immediate topic after a layman's rule. Okay. So layman's law comes under program evolution dynamics. You have to explain uh, the first law, second law, what does the first law says, second law states, the third law states. Okay. Then the fourth law, fifth law. There are 5 basic laws of a layman's. So you can refer the book to explain what is a layman's law. Because why I'm explaining, because explain the uh, uh, program evolution dynamics using layman's law. So that time it is not that simply you draw the table and show this table. You have to explain the one by one what are the first law, second law, third law as such, right? So the first law, actually the system maintenance is an inevitable process. Second law states that the system is changed, its structure is degraded. So whenever the system is changed, the system is degraded. So theoretically you can explain, uh, you find it difficult to understand the concept. First law says that always the system maintenance is an inevitable process because you cannot avoid the system maintenance. The second law says that any changes to the structure, so structure is degraded. changes in the system says that structure is degraded, right? The third law actually based on the interesting concept, right? Whenever we have large systems, so how do they establish that the law is based on the development process? Similarly, you can refer the fourth law. It depends upon the project work, that is a saturated point. So fifth law is concerned with the change in increment in each system release. Okay, so you can go through the book what all the layman say about the laws. So let me go directly to the today's major topic called software maintenance. So what is maintenance basically? So basically modifying a program. In fact, he has given the definition as modifying a program, but in your view, software maintenance is that you need to maintain so that it is working properly. Nothing should happen to the particular software, right? So in general, it is a process of changing a system after it has been delivered. The system is being delivered, right? So there are three different types of software maintenance. Okay, let me go to the point directly. So there are three types of software maintenance. One is fault repair, environmental adaptation, and functional addition. So let us see. Yeah, we have three types of maintenance. So first is a fault maintenance. So fault repair, that is an error, fault, or a failure. Usually they are relatively very easy. They are design errors. So they could be involved, they may resolve by rewriting the several program components. Okay. So second is environmental adaptation. So environmental adaptation, what is the meaning says that this type of maintenance is required when some properties of the system environment such as the hardware or the platform operating systems or other support changes, right? So maybe you may change the database support, that time the hardware compatibility to support your software, right? Such changes are being done in environment means what? The environment in which you are working with the platform, maybe the hardware, right? So here basically this application system should be modified to adapt to the, that is adapt or cope up with the environmental changes. Fine. This is the second maintenance. The types, what are the different types of maintenance? The first maintenance is a fault repair. See, overall, try to understand maintenance. It doesn't mean that it is simply maintaining. How do you maintain that? To see that error should not happen. If at all error are there, you should be able to eliminate. And what sort of errors you will come across? Environmental changes. That is, suddenly hardware will change. You have the same software, hardware change. So how do you adapt to the current hardware system? So that is a environmental adaptation. Fault repair. Fault is what? Fault leads to failure, I say. So fault is not, you cannot compare a fault with an error. Error is something that doesn't leads to execute the program. Fault will help you to execute the program, but fault will be identified only when the program is executed. Try to understand what is fault. Fault is not, you cannot say fault is a completely error. Error doesn't lead to execution. Fault will be identified only during execution. Try to understand. Fault will be identified only during execution, which will lead to the failure of the system. Okay. So when we talk about a fault, only during maintenance. Clear? So next, third is functionality additions. This maintenance to add, that is, you need to add some functionality. That is, this type of maintenance is only used when the system requirement change in response to the business, right? Some sort of additional features has to be added. That time this type of a functionality addition to add or modify the system functionality. Okay. So this diagram is one of the diagram to represents the maintenance distribution. See, actually this diagram shows a approximate distribution of maintenance cost of how do you distribute the cost. Okay, that is, it depicts the percentage that vary from organization to another. That is, how does the repairing system fault. We are just comparing the various the provisions or the statistics, how much, that is how much expensive the maintenance activity will takes. Okay, okay, you could see fault repair is only 17%, environmental adaptation is 18%, whereas adding the functionality, that is addition or modification, it takes 65%. Those were really uh, have understood the concept of software maintenance. What is software maintenance? Software maintenance, obviously it is nothing but maintaining a software, so when it is being given completely to the user, but there may be some sort of maintenance. What sort of maintenance? One is a fault repair. Fault repair, I said, it is not an error. Fault repair is identified only during the system run, that is when you are running the system during the execution, that may lead to failure of a system, and faults are only identified not during prior to the program execution. After program executed successfully, you are able to identify the fault. So the maintenance cost, it is a cost wise percentage that is required to identify the fault repair is 17%, whereas environmental adaptation is nothing but change of a hardware suddenly, so coping to that particular hardware is 18%. We have cost wise we have to spend 18% of the capital, whereas functionality addition, any sort of functionality or a features to be added, so it is same as if like changing the system 50%. Try to understand. So it is changing the system 50%, that 65% of the cost has to be spent in order to modify the functionality or addition of the modification. This is an important topic, software maintenance, that is being asked. Explain the types of maintenance and explain it. So you need to explain with this diagram. So cost wise you need to explain what could be the maintenance cost. Okay, so let me go further. See, that is what usually greater than the development cost means. How does the maintenance does? So first point I would like to say, even in the last class I stress, maintenance is one of the major factors. Sometimes the maintenance costs more you than the development of the system. See, these are all the various factors that he has given it. So before I explain, aging factor, that is asset deterioration. As the uh, software goes on proceeding, it becomes a old software. Aging software can high support cost, so it has to be supported at higher cost. As it is a senior, the or else as it is a old software in the system, so increase maintenance corrupts the software structure, so makes further maintenance more difficult. Usually greater than the development cost, it is double. So we are just discussing about the maintenance cost. So this diagram depicts how the comparison of the maintenance cost with respect to the three types of maintenance and overall maintenance cost. Okay, so this diagram, development and maintenance cost, shows the overall lifetime cost that may decrease, see, try to understand. This diagram depicts the lifetime cost that may decrease as more effort is put during the development to produce the maintainable system. So there is a comparison between the development cost and the maintenance cost. And see here, this block is a maintenance cost. This block is a maintenance cost. So here two systems are being developed, right? two systems are being developed. So in system one, you could see the development cost is, maybe if you consider in terms of a dollars, right? So maybe $25,000 are invested in making the system more maintainable. Whereas in the case of system 2, so we have spent more cost on the maintenance. So this is just a diagram to compare how exactly the development cost and maintenance constants could be compared, right? So because once the product is being developed, it has to be maintained, right? So a comparison of a development cost, you could say in system one, it is almost an equal 50% of the development cost is equal to the 50% of the maintenance cost. Whereas in the case of system two, you could see completely development cost has taken less, whereas almost 100% I would say it's totally the cost is on the maintenance. However, there should be a plan based development. So in order to see that maintenance cost should be equal matched with the development cost. Okay. So there are some other concepts. Okay. So before I go to the topics, there are one of the topic called maintenance prediction. So this is an important topic today we need to cover and we need to continue. So what is a maintenance prediction? This is a one of the major topic under software maintenance. What is maintenance predictions? That is, what is prediction? Prediction is nothing but you just guess, right? The estimate. So this could be prediction. For example, you have an exams, whether you have a February, we do predict after corona is over, definitely maybe on February you'll have an exam. This is a prediction. So same as if like what is a maintenance prediction, right? So usually if you could consider a scenario, what is, when do we do a software maintenance? So that is, we are going to predict what system changes might be proposed, what could happen in future, right? So it is simply an idea to predict what does the system changes, what system changes might happen, could be proposed, and what part of the systems are likely to be most difficult, which part of the module is very difficult to maintain. Okay, so with respect to this, we are going to estimate the overall maintenance cost. Maintenance prediction is nothing but we are going to estimate the overall maintenance cost for a system. So that is in given period of time. So we have one of the diagram to show this, right? What is these predictions and associate questions? Okay, with this thing today, the our coverage is on based on the maintenance prediction. So all of you could see this is a diagrammatic representation of a prediction, right? This diagram shows the prediction and associated questions. So you could see what could be the associated questions and the predictions. So predicting the number of change requests for a system, it requires understanding of the relationship. Okay, so let me go to the diagram once. So what parts of the systems will be most expensive to maintain? This, as I said once, what will be the lifetime maintenance cost of this system? These are all the functions predicting maintenance cost. Cost wise, you need to predict what will be the lifetime maintenance of the cost of the system. What will be the cost of the maintaining the system over the next year? For the next year, what will be the cost? Because prior to it, I have shown you always the development cost compared to the maintenance cost is more whenever you develop a system. What part of a system will be the most expensive to maintain? What part of the systems are most likely to be affected by the change request? Predicting the system changes, predicting the maintainability, predicting the with respect to the maintenance cost. How many change requests can be expected? So even this is a part of a predictive maintenance. So overall, to evaluate the relationship between the system and environment, we should assess the number and complexity of a system interface. That is, the large number of interfaces and the more complex the interfaces, we are going to interface changes that is being required for a new requirements. Okay. So a simple word, after a system which has put into a service, we should be able to process the particular data and we need to predict the maintainability. So there are many metrics that can be used for assessing the maintainability. Okay, metrics is nothing but the number of measurements that you could see. So software maintenance, you know what is software maintenance. So all of you are going to explain software maintenance with this diagram, types of maintenance and the maintenance for distribution. After that, immediately you compare the development and maintenance cost. So coming to the concept of maintenance prediction. So what does the maintenance prediction consist of? So it is nothing but an estimation with respect to the various point, that is predicting maintainability, predicting maintenance cost wise, predicting the system changes. So with respect to that, these questions are you are going to answer it, right? And also there are several metrics. So let me go to the metrics before software re-engineering. What is software engineering? So there are few of the metrics. Okay. These are all the process metrics. So that can be used to assess the maintainability. Okay. That is the number of requests for correct maintenance, for corrective maintenance. The maybe the average time required for impart analysis. So average time taken to implement a change request. So here are the matrices. Okay, that was I was explaining. Number of requests for corrective maintenance. So the question could be, what are the metrics for required that is being used for assessing the maintainability under predictive maintenance? Under predictive maintenance. So you need to explain these four matrices with the explanation. So next immediately is software reengineering. Before we go to the software reengineering, so let us take one more session on the concept of to explain this software maintenance, but try to understand what exactly it is being happening here. Okay. So under software maintenance, once again, I like to go to the syllabus. See, the topics look small, but internally there are many data that is being hidden. For example, today we just started software maintenance. So overall brief up, you may be asked what is software maintenance, explain the types of software maintenance. That could be the first question in this topic. Immediately you could be asked, explain the predictive maintenance. What is the meaning of predictive maintenance? That is maintenance prediction. Predictive maintenance is nothing, maintenance prediction. You may ask what is predictive maintenance. Third question you may be asked inside is what is software reengineering? We have not just started. So three questions may be asked within software maintenance. And last topic is the small topics, legacy system management. So anyway, that could be covered up. If I left also, maybe I have a plan to start fifth module next week, right? So any left out topics could be covered, hence it is an online class, that is not an issue. All right. And evolution process is also a major topic in which there are many subtopics. So whereas program evolution dynamics is a single topic where you have to explain the layman's laws, 5 layman's laws with the table you need to explain. Whereas release testing is a complete subtopics we have, user testing very many subtopics we have, test driven. So once again, those who have not able to concentrate into the class, or those who are not able to understand, it is not that uh, as I said, remember when I started these sessions, software engineering sessions in the beginning, uh, there are different levels to understand the concept of software engineering. It is not that you can understand the concepts to an extent of 100%. Definitely you need certain kind of maturity to understand the concepts. Got it? When you have started the concept of programming, it is not that few people have understood initially itself. Few people have not understood the concept in the beginning stage. Maybe in between of the semester they have analyzed, yes, the program is interesting. Maybe few people at the end stage, at the end of the semester, they have understood the concept. It is not mandatory. It depends upon the mentality. But thing is that your approach should be a proper approach. You should give some sort of interest toward the subject, then only you would be able to understand. That is what I stressed many times, right? You concentrate and you need to put effort from your side to understand what is the concepts of waterfall model, increment. Why do we need? Because so when you start with a project in your future semester, maybe in the 5th sem or a 6th sem or a 7th sem or 8th sem, so you find it difficult with respect to these terminologies. What are the functional requirement? What are the non-functional requirement? How do you collect the requirement specifications? So what is the meaning of validation? So all these things you find it difficult. Whereas we have covered module 2, 3. These are all the totally concepts of object orientation. The basic concepts of software engineering we have, that is mandatory for use module 1, module 3, sorry, module 4, 5. Only 3 modules are basic fundamentals that really explains you how do you could utilize these things in your projects or in your curriculum. So my request, it is a humble request, I would say, just go through the book, try to understand, try to read through the books. It is not that only for examination point of view study it. So for future point of view also, these concepts are too much important. And don't treat this as a theory. And we have few of the for examination, definitely as I go on PPT, I say evolution process, remember this T diagrams, you explain it. Definitely your job is done. But the thing is that yeah, for your career point of view, you need to understand the concept properly. Again, if I say user testing, you can explain alpha testing, beta testing, and acceptance testing with diagrams. Your job is over. It is that when do we go for alpha testing specifically, beta testing before release? So if you could Google beta testing, you could see always a software before release, they do give a copies of a software to the user to test. So in order to identify the flaws, even whenever a game is the beta version of the game is being released, beta version of the software is being released as such. So today let me start the session. So software maintenance, as I said, we just started software maintenance. We have gone through only the few products. Predictive maintenance or maintenance prediction we have seen, right? Types of maintenance we have seen, and we have one more topic, software re-engineering. So that we have to cover, and we have to cover legacy system management. With that we need to start with the module 5. So hardly we have 3 sessions in the week, and all of you, those who have not given the attendance, can give in the chat session, right? And we have to cover up. So maybe I go a bit fast in order to cover up the module 5, because we have not assure of internals. If suddenly comes, we have to cover up all the module 4 and 5. However, I complete, so that will be there. Module 4 and module 5 will be there for your internals, and eagerly I'll post you the um, uh, assignment 2. So that might cover a few questions from module 5 also. You need to go through module 5 and write it. As maybe the due date I'll just extend. Okay, so those who have not given the attendance on the chat session can give into the chat session.